This will give you the full comprehensive guide as to everything you need to know in order to solve any circle question you will ever encounter in your life. Now, for circles, it's pretty much just broken down into two things when it comes to circles. And that is when we are talking about properties of circles. We have the symmetrical properties as well as the angle properties. And for symmetrical properties, we have 4. And for angles properties, we have 4. And that's pretty much it. And of course, with special cases, which I will, we'll go through a little bit more in subsequently. So for symmetrical properties of circles, symmetrical properties, there's really only 4. Now, number 1, consider this circle over here. This is a circle, and this is the center of the circle. Now, when I have a line inside the circle that is, does not cut through the center of the circle, we call this the chord. And this chord can be linked to the center of the circle with this line, right? And this will be the angle, a perpendicular bisector of the chord, because it cuts through the center of the chord and it's at 90 degrees. So for the first one, let's call this A, B, and then we call this point M. So OM is perpendicular to AB, and at the same time AM equals to MB, and we will call this reasoning perpendicular bisector of chord passes through center of circle. Number 2, consider this circle over here. Now we have 2 chords, and then we have a center of a circle, and these 2 chords, the perpendicular bisectors of these 2 chords will cut through the center of the circle, as you can see over here. And now let's just label these chords over here. So this is A, B, this is the center of the circle, let's call this C, D, and let's call this M and N. So in this case, AB will equals to CD if and only if OM is the same as ON. So if the length OM is the same as ON, then the length of the chord AB will equal to CD. And for the reasoning, we call these equal chords, are equidistant from the center of the circle. Number 3. Now consider this circle over here. We have the center of the circle, let's call this O, and we have a tangent. Now, this tangent, the perpendicular bisector of this tangent, or rather the normal of this tangent, will cut through the center of the circle, and this will also be 90 degrees. So in this case, for any tangent that touches the circle, the normal of the tangent, which is this, that cuts through the center of the circle, the angle between the normal and the tangent is always 90 degrees. So let's now just label this A and B. So angle OAB is 90 degrees, and we'll call this tangent radius. Number 4. Now consider this circle over here. And then we have a external point over here. And we have 2 tangents to the circle that cuts through this point over here. Now, these 2 tangents that comes from this external point over here, Let's name this external point T, and we call this point of intersection A, and we call this intersection B. In this case, AB, or rather AT, will equal to BT, and they are the same length. And the point of intersection, which is the T, if you draw an angle bisector through T, it will cut through the center of the circle. And in this case, AT will equal to BT, and we call this tangent from exterior point. That's the reasoning. So those are the symmetrical properties of a circle. And now we move on to the angle properties. So now for the first angle property of a circle, we have what we call angle at the center equals to 2 angle at circumference. So consider this center over here. This center is formed by this line and this line, right? It's subtended by this arc over here. This is the arc that is subtended by. And likewise, at the same time, we have another angle formed by the same arc. Let me just redraw this over here. So as you can see over here, this is angle A, this is angle B. And in this case, angle A will equals to 2 times angle B. And we call this angle at center equals to angle at circumference. Now it doesn't matter if it's directly above. It can even be this case where it's here, as long as it's a straight line. It can even be here, and you still follow this. In fact, it can also be here, and it will still follow this as well. Now, next. The next rule that we have is what we call angle in semicircle. So if you have a semicircle, that means the line over here is the diameter of the circle. Let's call this AB, and let's call it angle over here. Let's call this O. In this case, angle OAB will equal to 90 degrees. And we call this angle in semicircle. So as long as the diameter, which is AB, forms any angle that touches the circumference of the circle, it will be 90 degrees. So it can even be in this case where it's here, right? This will also be 90 degrees. It can also be this case over here, and this will also be 90 degrees. So that is how you see it, as long as AB is the diameter of the circle. Next, now consider this circle over here. Now we have this third property called angles in the same segment. Let me just redraw this. A, B. In this case, angle A will equals to angle B because they are angles in the same segment. Angles in the same segment. And how can you tell whether they are in the same segment or not? First and foremost, they are both formed by the same arc. Right? They are formed by the same arc over here. For A, it's formed by these two lines which touches this arc over here. And for B, it's formed by these two lines which is formed by the same arc over here. And since they are formed in the same arc, by the same arc in that fact, and they are in the same segment, meaning to say that this, if you draw a horizontal line in between the 2 points of which the two circles are over here, this is segment 1, and then the rest over here is segment 2, and they are formed in the same segment. And since that's the case, they are the same angles. Now this is different from this fourth property over here. Now consider this circle over here, where you have these two angles. So this is one angle, and then this is another angle. These two angles, A and B, they are 180 degrees, or in other words, they are supplementary, and we call them angles in opposite segments. And how do we know that they are in opposite segments? First and foremost, they are formed at the same point over here, right? That's true. It's same as this. They are formed at the same 2 points over here. However, angle A, which is this line over here, is formed by these two lines, which is supported by this arc over here. So there's a dotted line over here. Whereas for B, it's formed by these two lines over here, which is formed by this arc over here. So they are formed in different segments, although they both are formed by lines that touch at the same points. And this is why they are in opposite segments. So this is the first segment over here, and then this is segment 1, and then this is the opposite segment, segment 2. So this is everything you need to know when in regards to come to circles. So just to recap, for circles, there are symmetrical properties, there are angle properties, there are 4 symmetrical properties, namely your perpendicular bisector of chord, equal chords are equidistant from center of circle, tangent radius, tangents from exterior points, angle at center of circle equals to 2 angle at circumference, angle in semicircle, angles in the same segment, as well as angles in opposite segment. And now we just add on one more, which is the special property of circle. Now this is tested in additional math or A math, and it's not tested in your normal math or E math. So if you take A math, this will be applicable to you, and if you don't take A math, then this will not be tested for you. So in circles, there is one more thing called the tangent chord theorem. And the tangent chord theorem states that as long as you have a tangent, right, that touches the circle over here, assuming that this is the tangent that touches the circle over here, and let's call this A, B, and we call this point of intersection C. And this point of intersection, it touches this chord over here. Okay, it touches the chord over here, CD. And CD forms this angle over here, which touches the circumference of the circle, just like that, and we call this E. So with this angle over here, which is angle BCD, and this angle over here, angle CED, so angle BCD is exactly the same as angle CED, and we call this reason angles in alternate segments. So how do you identify this? First and foremost, you must have a tangent. The tangent then intersects this chord. It then comes into contact with the circle at the same point as the chord, which is over here, and this chord forms an angle at the circumference of the circle. And if these 3 conditions are met, then you have the tangent chord theorem, where you can then state that the angle formed between the tangent and the chord, so angle formed between tangent and chord, equals to the angle formed by the 2 lines from chord, in very layman terms. So these are the 2 lines formed by the chord over here, and that is all you need to know for math in order to score well for it. I hope this video has been helpful. If you like more resources as to how to help you score A for math, you can go ahead and click the link in the description under this video. If not, do consider subscribing to this channel to receive regular daily math videos from me. If not, thanks for watching, and I'll see you in the next video.